guys, this is Mrs. Bolin here with your notes for section 9.2, graphing exponential functions. So we're going to start with a little bit of review from last week. So for the warm-up, we are evaluating, and remember that anything to the 0 power is equal to 1. The exception would be 0 to the 0 power, which is undefined. For the next one, we're going to simplify here. If we've got 2 4s being multiplied by 3 4s, then that means that we have 5 4s being multiplied all together. And we know that 4 times 4 is 16, times 4 is 64, times 4 is 256, and times 4 is 1024. 1024. Couldn't have been a little one, could it? I had to memorize all those when I was in high school. So back in the olden days, we had calculators, but our teachers made us memorize everything. So question number 3, we're going to simplify. So remember that we multiply the exponents here. So we have 2 to the negative 4, which is equal to 1 over 2 to the 4. Because remember that negative exponent doesn't mean my value is negative. It means I'm doing the inverse operation. And so instead of multiplying by 4 2's, I'm dividing by 4 2's. And so we take the reciprocal, or you can just say these are unhappy. They are negative where they are. So we need to move them and make them happy, and then they are positive. And then if I have 2 times 2 is 4, times 2 is 8, times 2 is 16. And that is my final answer. And then for number 4 here, this last one, if I have 2 7s in the top and 5 7s in the bottom, I am going to cancel any that are the same in the top and the bottom. So I always ask myself, where are there more 7s and by how many? Well, there's more 7s in the bottom, and there are 3 extra. So I go 7 times 7 is 49. 49 times 7 is 343, I think. So 1 over 343. All right, you guys are welcome to use your calculators for those. Yes, we're going to go ahead and go on to the notes now. So we are looking at exponential functions. Okay, so last week we talked about the properties of exponents. Now we're going to look at the relationship between x and y when x is an exponent. Okay, this is different than a linear function where we had y equals mx plus b. So x was just being multiplied by something, whereas now x is actually the exponent. So in a linear function, it makes it's not really a straight line, but it looks like this, right? That's a linear function, whereas an exponential function, instead of increasing by the same amount each time, it gets multiplied by the same amount each time. So what that looks like for our exponential one is that it starts growing, and then it grows really, really fast. Okay, so for example, if I said, I'll give you $1 for your allowance and then I'll double it every day, or would you rather just have $100 every day? A lot of people would be like, oh, I want 100 instead of $1. But if you think about the way that that $1 would grow when you keep doubling it and doubling it and doubling it, pretty soon you would be like at $1,000 a day, $2,000 a day, $4,000 a day, and it would keep climbing up. Starts out kind of slow, right? But it climbs very quickly, whereas the linear just keeps adding the same amount every day. I got 100, I got 100, I got 100. My bank account would just keep going up by that same amount. Whereas this one, it's getting multiplied. And then if I'm adding that in there, my balance would be really big. Okay, so what does that mean for you guys? Here's what we're going to do. We're going to look at the patterns, remembering that exponential functions are getting multiplied by the same value every time. And think about if you're multiplying by a fraction, that's just like dividing, okay? So if there's a value in the bottom of a fraction, what's going to happen to it is it's going to get cut in half, cut in half, cut in half. Okay, so if your base is a fraction that's smaller than 1, but it's still positive, we're going to be going down like this. And then just depending on whether the a value out in front is a positive or a negative, it will either go up or down in the positives or the negatives. Okay, same thing over here. Let's go ahead and look at some problems. Okay, you guys. So looking at problem number 1, it says, does each table represent a linear or exponential function? So remember, the linear is where we added the same time every time. I found the difference. But if I look at this one was times by 2, times by 2, times by 2. So this one is going to be exponential because it's being multiplied. Let's look at this one. This one is being added by 2, added by 2, added by 2. So this one would be linear because it goes up or down by the same amount every time, plus or minus. Exponential is multiply or divide. Okay, question number 3, evaluate it for the value of x. So I'm going to take this value and I'm plugging it in for the exponent. Okay, and so what we have is y equals -2 times 5 to the 3. Well, it is so tempting, you guys, just to do 2 times 5, but you can't do that, right? Why? Because of order of operations. Remember, please excuse my dear Aunt Sally or whatever your teacher taught you for that, PEMDAS. Okay, so inside the parentheses, everything's simplified. That E stands for exponent. So we have to do the exponent part before I can do the multiplication part. So if I have 5 to the third, we remember that's 5 times 5 is 25. If I have 5 quarters, that's $1.25. So I know that's 125. So y equals -2 times 125, which is -250. Okay, and that's our value for the function when x is equal to 3. Okay, question number 4. This says evaluate the function for this value. So we're going to plug in the -2 right there. This one's a little bit trickier, you guys. So we have 3. I'm going to write this as 1/2, and then we have that to the -2. Well, remember how we talked about this negative just means the inverse or the reciprocal of what's inside. So instead of multiplying by 1/2 each time, I divide by 1/2, which remember, if you divide by a fraction, copy dot flip. So I'm just going to flip this over and take care of that negative. So I'm going to say y equals 3 and then 2 to the 2. So the fraction and the negative kind of canceled each other out. You can't cross them out like that, but really they are inverse operations on each other, okay? And so what we did was we divided by a fraction, which is the same thing as multiply. So then I have to do the exponent first. So I have y is equal to 3 times 4, which is 12. So the function equals 12 when x equals -2. All right, now we're going to graph some, you guys, and then we're going to get on with the homework. Super easy. So what I like to do is start with the easiest problems and then see if I could fill in with the pattern. So I'm going to plug in 0. So I have 4 times 2 to the 0. Well, remember, anything to the 0 power equals 1. Okay, so what is 4 times 1? That would be 4. Okay, now I'm going to plug in the 1. So I'm going to go 4 times 2 to the 1. Well, 4 times 2 is 8. Then I'm going to go 4 times 2 to the 2. Well, 2 to the 2 is 4. So 4 times 4 is 16. Okay, so I could plug in these numbers. So 4 times 2 to the -1. Well, -1 means divide by that many 2's. So that would just be 4 divided by 2, which is 2. And then I could plug in the -2, 4 times 2 to the -2, which is 4 divided by 2 2's. Well, 2 times 2 is 4. 4 divided by 4 is 1. I could also have just used this to fill out the pattern, right? This, I'm like, oh, divide by 2, divide by 2, divide by 2, divide by 2. Could have got the same answers that way. So I'm going to start by plotting them 0, 4. And I'm noticing here, I'm going to run out of spaces, right? So I need to pick a scale that will work. I need to go all the way up to 16. So I'm going to go by 4s, I think. So 4, 8, 12, 16. So 0, 4 would be right here. 1, 8 would be right here. 2, 16 would be up here. Then I'm going to go backwards. -1, and this one I'm just going to keep 1, 2, 3, 4. So I'm going to go -1, and then 2 would be halfway up to 4. And then -2 would be at 1, which would be 1/4 of the way. And these, here's my favorite word for this lesson, you guys. These functions have what are called asymptotes. Okay, and that is spelled asymptote. So in case it sounded like something else, it's called asymptote, which means it's a line that gets closer and closer and closer and closer to another line without ever touching. Okay, so this is going to get closer and closer and closer to zero without ever crossing through. And this side is just going to keep going up like forever. And this is going to go back forever. So that's what the graph looks like for that one. This next one's a little bit more difficult. This is a divide by problem because we have the 2 on the bottom of the fraction. So I'm going to start again by plugging in 0. So if I have anything to the 0 power, that's just equal to 1. If I have 1/2 to the 1, that's just equal to 1/2. If I have 1/2 squared, that just means that I have 1/2 times 1/2, which is 1/4. And then now I'm going to go the opposite direction. So if I plug in a -1, here's where it gets a little bit dicey, you guys. So here's what that looks like. There's not a ton of room to work here. So I'm just going to 1/2 to the -1. Remember that negative means do the reciprocal. So I can flip that fraction and get rid of the negative. So I'm going to rewrite it as 1/2 to the +1. Well, if I have 1/2 to the 1, sorry, I didn't flip it. I did that on purpose. I was seeing if you guys were paying attention. Just kidding. So that's if I flip it, that's what it looks like, 2/1. And then I have 2 to the 1 power, which is just a 2. I know it feels super weird to have a fraction raised to a negative number and then just get a plain old 2, right? Okay, this one, I won't try to trick you on this one. So now we're going to take the 1/2, we're going to raise it to the -2. I am going to flip it over 2/1, and now my exponent is positive. So I have 2 to the 2, which is equal to 4. So now I'm going to graph this. I'm going to start with 0, 1, then 1 and 1/2, 2 and 1/4. I'm back at -1, +2, and -2, +4. So you'll see it follows the same kind of pattern as this one, but kind of like a mirror image of it. So whenever we're dividing by a number, it's really high over on this side, and then it has an asymptote over on the positive direction. It gets closer and closer and closer to 0, but it will never actually cross it because I'm just going to keep taking half, taking half, taking half, taking half. I'm never going to have, I'm never going to run out if I only take half of what I have left, but essentially it's going to be really close to 0. So that is it for your notes. We are going to move on over to the odd homework problems. So question number 1 says, does each table represent a linear or exponential function? Please explain. So this one, to get from 1/4 to $1, I multiplied by 4. To get from 1 to 4, I multiplied by 4. 4 to 16 times by 4, 16 to 64 times by 4. So this one would be exponential, and it has a constant ratio instead of a constant difference. So you could say multiply by 4 each time. Okay, sorry, that's kind of a mix of my cursive and print. Sorry, you guys, that says multiply by 4 each time. This is an exponential function. Okay, question number 2, we're gonna skip because that one is an even one. But look at the pattern, +2, +2, +2. Okay, number 3, this one I did times by 2. This one I did times by 2. This one I did times by 2. This one is also exponential because we multiplied by 2 each time. Okay, question number 5. Evaluate the function for the given value of x. So I'm going to plug in that 2 because this is x equals 2. I'm going to take the 2 and I'm going to plug it where the x is. So I'm going to write this out. Y equals -4 times 5 to the power of 2. Remember, we cannot do 4 times 5 first. That comes later. We have to do the exponent first. So I do 5 squared, which is 25. And then 4 times 25, well, if you have 4 quarters, that's $1, so 100. So y equals -100. And this negative is very different than a negative that we have in an exponent. This one doesn't mean divide, it just means our answer is negative, okay? So that is the value of the function when x is 2. Moving right along to question number 7. So now for this one, if I'm going to graph, I'm going to start plugging in the easy ones, right? 2 to the 0 is equal to 1. 2 to the 1, if I just have 1, 2, that's 2. 2 to the 2, well, that's 2 times 2, which is 4. 2 to the negative 1 just means divide by 2. So that's like 1/2. 2 to the negative 2 means divide by 2 2's. So that would be 1/4. So I'm going to graph this one. Negative 2 is 1/4. Negative 1 is 1/2. 0 is 1. 1 is 2. And 2 is 4. Remember, this is the x direction. This is the y direction. X is side to side. Y is up and down. And then that is what our graph looks like. Okay, number 8, we're going to skip. You cannot just cancel those. You have to do the exponent first. Some of them, once you plug in the exponent, you'll be able to cancel, but you can't start with that. Okay, number 9. Here's the super fun one because we've got this fraction in there. Well, remember, if I plug in 0 to anything in the exponent, that's going to equal 1. If I have 1/2 to the 1, that is going to equal 1/2. And if I have 1/2 squared, that means 1/2 times 1/2, which is 1/4. If I have 1/2, oh, what did I forget to do? Again, just testing you. No, just kidding. It has this -1 out in front. Whoopsie, whoopsie. So if I multiply all those by -1, that has nothing to do with my exponent. That only has to do with the value that I get at the end. It's going to be negative. Okay, so if I have 1/2 to the -1, that means I flip this. So I have 2 to the +1 times by the -1 would just be -2. And then if I have 1/2 to the -2, that means I'm doing the reciprocal of that, which is +2 squared, which is 4. And then if I do 4 times that -1 out in front, that -1 just makes all of our answers negative. Okay, so now we're going to graph that, see what it looks like. At -2, I've got -4. At -1, I've got -2. At 0, I've got -1. 1 is -1/2, and 2 is -1/4. 1/4, a fourth. And then we graph those. Remember, we have that super fun word asymptote. It gets closer and closer and closer to the line, but doesn't cross it. Okay, last one here. Question number 10. This says, describe and correct the error in evaluating the function. So look what they did, you guys. They did the multiplication first. No, we can't do that because of PEMDAS, right? Please excuse my dear Aunt Sally, or GEMDAS with grouping instead of parentheses. So I cannot just go from there to there. We cannot do that, okay? So we have to take the 6, and I'm gonna write this as a fraction. So 0.5 is 1/2 to the -2. Well, remember that negative means the reciprocal. So I'm just gonna go 6, 2. I'm gonna flip this and get rid of the negative. Wow, that looks so much better, right? So 2 squared is 4, and then 4 times 6 is 24. And oh, that was an even one. Sorry, bonus. You're welcome. All right, that is it for our 9.2 notes for graphing exponential functions, and I will see you tomorrow. Bye, you guys.